Hello everyone, my name is Abinash Rai and I'm gonna talk about solar simulator. Firstly, I would like to express my special thanks of gratitude to my physics teacher Dr. C.P. Khatibada sir, who gave me the golden opportunity to do this wonderful project on the topic solar simulator. So what is a solar simulator? A solar simulator is a light source that approximates the illumination of natural sunlight. So here are some images of solar simulator. So why do we use a solar simulator and not just any of the light sources that give us of white lights? Well, a solar simulator are used to provide illumination that closely resemble natural sunlight, so the indoor testing can be controlled to check the performance of different devices and conduct different solar research projects. So characteristic of the solar simulator has been regulated to comply with standard form different application. This application can be used to test photovoltaic devices such as solar panels for the chemical batteries or even to test cosmetic products. It would also be used to test thermal power generator and also to test consumer electronic goods such as cell phones, cameras, photochromic lenses, or it could be used to test industrial or building materials such as plastics, paints, textiles. Now, solar simulator can also be used for research studies in biological and medical sciences, such as cancer research, for the synthesis studies and biosensor analysis. So, why is solar energy so important to us? Earth's primary source of energy is radiant energy from the sun. The amount of intensity of solar radiation that location receive depend on a variety of factors. These factor includes latitude, altitude, season time of day, and cloud cover and so forth. Now all radiant emitted from the sun which is Earth's surface and lot of it absorb, reflect or scatter in the atmosphere. On the earth, solar energy can absorb directly from the sun. Now this is called radiant direct radiation. Another type of radiation is from light and that has been scattered as if enters inner atmosphere, which is called indirect radiation or global radiation with a solar simulator. Radiation absorbed at different conditions of the earth can be simulated with the use of filters and optical configuration. A solar simulator can also be emit solar radiation observed in space. Now we will discuss how to imitate this different form of solar radiation. Now if you open a solar simulator, we will find that essentially it is a lamp source which carefully resemble optical and electrical component. There are few main components that one must take into consideration. Will have a lamp source in varying voltages. These voltages will depend on the illuminations area, how uniform we want the light source to be, and also how collimated we want the light ray to be. The light source will be inside a lamp housing. This is essentially a light lighting enclosure. Will have optical components such as lenses, back reflector, and an igniter. The solar simulator also contain a power supply for the lamp. There is also an air mass filter used to filter the light beams to match the solar spectrum. These air mass filters can vary depending on the type of spectral condition we want to imitate. Optionally, we can also include neutral density filter to change the intensity of a light, as we can also add long and short pass filter to isolate certain part of the wavelength spectrum. So the characteristics stimulates from a solar simulator are spectral, math, spatial uniformity, temporal stability, and adherence at the target of illumination, and the collimation angle of our output beam. So the top of the figure on the top left show the wave bands of the spectral distribution for the different reference condition. As a light source, sun produces an extremely uniform illumination. Therefore, uniformity of a output beam of a solar simulator should ideally be as uniform as the sun, as you can see in the figure. And the most important is the solar irradiance. The solar irradiance is also important for most research project. Now, solar irradiance is the intensity with which radiation enters Earth atmosphere. The solar radiance flux on the area is measured in watt per meter second. In ambient condition, natural sunlight gives 1000 watt per meter per square meter. So therefore, 1000 watt per meter square is defined as one sun. As a solar simulator using a AM 1.5G spectral filters will give one sun of a power density at the target illumination. But the sun is so far away from the earth that the solar rays that incident occur are nearly parallel to each other. The conversion angle is 0.53 degree. So for all intent and purposes, the sun rays can be considered as highly parallel, or in other words called collimated. So thank you.